Everybody, we are in Unit 3. We're going to do the Lesson 11 practice problems. So give these a good try on your own first, and then this is a great way to check some of your thinking and check your solutions too. So I'm going to talk through it with all my thinking as I go through these. Lesson 11 in Unit 3 is talking about complex numbers. So we've got one here, and it asks which point represents the complex number -3 plus 2i is where we start. So just a reminder that this is the real part of it. So if I start here from the origin, I'd be moving this way to get to -3. So that's the real part. Remember, that's our real axis first, and then this is our imaginary. So I already have it eliminated down to A and D because I know I'm going to -3. And then that imaginary part of it is what we see next. This is a plus 2i, so positive 2i. And when I look at that, that 2i is up here. So I would be then going up to a positive 2i, and that's going to be point A on our grid. If we need to match each expression to an equivalent expression, so this is starting to think about how we would multiply or use exponents with I. So I want to first of all show you a couple things, how to do these first by hand, and then also how you can use a calculator to check it, because that's pretty important. So if I have 2 i's and I'm multiplying it by 8, that means I have 8 2 i's. So I could really think of it like this, that I'm adding all of these kinds of i's together. 1, 2, 3, 4. I've got 4 of them. I need 8. But really, if there's multiplication, I'm just going to multiply the 2 and the 8 and see that I would have 16i. So that's going to match with this one here. So A matches with 4 and 4 matches with A. The I is kind of hard to see. I realize that now. Now, if I have 16i to the third, that's going to get a little interesting. We haven't actually seen what 3 i's multiplied together looks like. So I know it's going to have a 16 to it, and I know it's going to be a positive 16, I think. What I know, I think we talked about this in lesson 11, is that if I equals the square root of -1, if I square that, so I squared and this squared, what we would have is that I squared is canceling out the squared and the square root. Those things cancel each other. So I squared is -1. So what this tells me is that if I think about it this way, I'm going to have 16 times a -1. Now that's 2 of the i's, but I still have another I here because I have I to the third. So I've got 16 times a -1 times I. Well, 16 times -1 is a -16, and there's still this one I here with it, so this is actually going to match up with our -16i. Now that one's a little advanced, I would say, for this lesson, because we've only talked about, I think, I squared at this point. So let me show you now how you could use your calculator to check some of these, okay? Our calculator can't do this real imaginary graphing, but it can do imaginary numbers. Okay, so it's only in our graphing calculator, or Desmos actually has this too. You can go to Desmos if you don't have a graphing calculator. And Desmos, you can change the mode, just like we're going to do here, check your mode, and put it in imaginary mode, or A plus BI mode, okay? Because that's what our complex numbers, we talked about that we have a real part and an imaginary part. So if you have a graphing calculator, hit that mode button, and here's where we're looking for this. I already have mine in the right mode. You have a real mode, or you have an A plus BI. Make sure that yours has it highlighted like that. All right, now when I quit, I can actually type in 16, and the I is right here above the decimal. So I can do second decimal, and what that does is it puts an I on my calculator. And I can raise that I to the third power just by using my regular exponent button. Now when I hit that, I see that it is in fact negative 16i. Let me show you on my screen too what that looks like. So I'm going to click here real quick and open up a Desmos. And a regular graphing calculator is going to have this, right? So what I'm going to do here is go to my wrench up here, and I see that I have a couple options here, grids and x-axes and y-axes. I have more options, which is kind of neat to look at, but I don't need those more options. What I need is this right here. If these are complex numbers, let's use complex mode. Right? Click that on, and now if we start doing these things, check out that it's going to start using real and imaginary. So now if I do that here, if I do 16, just the letter I, and I raise it up to the third power in Desmos, it tells me the answer right here, negative 16i. So this is a great calculator. And it actually does plot that here. Do you see how it, as soon as I put it into complex mode, it changed this into a real and an imaginary plane. So that's kind of cool. So that's right here. Okay. So let's check out the rest of these and let's see what else we have. I'm going to just add another one here. My next part C is 2i in parentheses, and then raising it up to the fourth power. Now when I do that, it tells me it is equal to 16. So I'm going to use that right here. That what that does is that means we have 2 to the fourth power, which is 16, and I to the fourth power, which equals 1, right? And that might not be real intuitive right now, that I to the fourth is equal to 1, but I to the fourth is really just I squared times I squared, right? Our rules of exponents tell us the same thing. And we already know I squared is negative 1, so this is negative 1 times negative 1, and a negative times a negative is a positive 1. So I to the fourth is just equal to 1. Now, our Desmos told us it's equal to 16, so I believe that. And so C is 2. And last but not least, I would have to assume that I got all the rest of these right. 2 times 8 is 16. I times I is I squared, but I squared is negative 1. 16 times negative 1 is negative 16. So again, you can use a calculator, you can use Desmos. It's got it. It's kind of cool. It's pretty awesome. All right, let's keep on. Question number 3 on the next page. Diego squared a number and got 4. Okay, so that means he took some number, he squared it, and he got 4. Andre squared a different number and he got 4. What were the numbers that Diego and Andre squared? Okay, well, we should know this idea by now, that if we have something squared and it equals a positive number, we're going to have 2 answers. And those 2 answers are, when we do the square root, we have to think about the positive and the negative square root of 4. So one of them used 2, the positive square root of 4, and the other one used negative 2, the negative square root of 4. Jada squared a number and got negative 4. Elena squared a different number and got negative 4. So I'm going to think about this now. What numbers are we looking at here? And so when I square root a negative, that negative is under the radical. I still need to think about a positive and a negative square root of -4. And a square root of a negative is always going to be I. Square root of 4 is still 2 and -2. So one of them used 2i and the other one used a -2i. And again, we can use a calculator just to show that and make sure that we've got that right. That if we do 2i squared, again, I used second decimal to get that I to show up. 2i in parentheses squared is a -4. And -2i in parentheses squared is also a -4. All right, so I'm going to use nifty notes. Maybe you put this in the back of your workbook, that there are different times that we're going to find different numbers of solutions. So I'm going to think about this here. I have a squared, something squared. It equals a positive number, so I know there's going to be 2 real solutions. So when I square root that, I'm going to find that a equals the positive square root of 1 and a equals the negative square root of 1. 1 and -1. When I square root part B, again, I have something squared equaling a positive number. There's still going to be real solutions. This just means there's no I in there. Now, square root of 13 on my calculator is not an exact number. So I'm just going to leave it as a square root of 13. So B could equal the positive square root of 13. It could also equal the negative square root of 13. Remember, if we start with something squared, 2 answers. If we start with a square root, there's only 1 answer. Okay, so using some of these ideas here. And we can also put that as a single thing like positive or negative square root of 13. You can write it shorthand like that. When I square root a negative, that's where the imaginary numbers are coming up. If we square root, if we start with something squared equaling a negative number, there's no real solutions, but there are 2 imaginary solutions. We're going to have I in these answers. So C is going to equal the positive or negative square root of -9. That negative tells me there's going to be an I involved. The square root of 9 is 3. And we could have a positive or a negative 3i. Okay, so C equals 3i, or it could equal -3i. And last but not least on this problem, we have D squared equals a negative number, something squared equaling a negative, no reals, 2 imaginaries. Five is not a perfect square number, so I'm going to keep that underneath the radical. But this negative can come out front as an I. It does get to leave the radical. So we have positive or negative I root 5 is how we would read that out loud. I square root 5. So positive I square root 5 and a negative I square root 5. We put the I in front just so that it's clear that it's not underneath the radical. You could write it as the square root of 5i. You just have to make it really clear that that I is not underneath the radical. Okay, make sure of that. I like to write mine like this. Most mathematicians write it like that. All right, just 2 more problems and we're good to go. Number 5 takes us back to solving radical equations. So this is back at lesson 8. So if you need to flip back to that for a quick reminder of what we did, do that. But I'm going to tell you what we do is we get the radical by itself. All right, and it doesn't matter what's here. We're going to get the radical by itself. We're going to use an exponent to undo. And then we're going to solve. And there's only one case that we're ever going to stop solving. And that's if we have a positive square root trying to equal a negative number. All of these are cube roots. So I'm using this idea that a cube root will always have one solution and only one solution. Okay, so cubes and cube roots, always one solution. So let's solve it. The radical is by itself here, so I'm ready to use an exponent to undo that radical. It's a cube root, so I have to cube both sides. Cube and cube root cancel each other out. I still have an a plus 2 here on the left side. And 4 to the third, no shame in this game, 64. So something plus 2 equals 64. Now I'm going to subtract 2. So after we use the exponent to undo the radical, we just need to solve for our unknown. Subtracting 2 from both sides tells me that a equals 62. Part B, get the radical alone. Right now, here's my radical. I need to deal with this plus 5 before I start solving. Opposite of plus 5 is minus 5. Cube root of b equals, a negative 1. Okay, that's all right. My thing told me it didn't matter if it's positive or negative. I'm always going to have one solution, so I'm going to keep on going. I'm going to use the exponent to undo the radical. Okay, now there's a reason why I keep on putting those in parentheses. Do it too. B equals negative 1 in parentheses raised up to the third power. Negative 1 is our answer. And last but not least, part C. Same thing, box in that radical. We're going to deal with everything else first and then deal with the radical. Okay, so we need to get the radical alone. In this case, I need to do the opposite of subtracting 14, so I need to add 14. Let's see, negative 4 plus 14 is a positive 10. I'm going to use an exponent to undo the radical. I have it by itself now, so I'm ready for that step. Cube both sides. Cube and cube root cancel. C minus 1 is all that I have left on the left side. 10 to the third power is a 1 with 3 zeros. And last thing is to solve for this variable. I got to get C all by itself. C is 1001. And our last one is just a thinking question, an explaining question. How do you know that square root of negative 1 is not a negative number? And the answer for that is it's not a negative radical. This is a positive radical. So it has to be a positive number. And if I type it in my calculator, now that I have this, it's a positive I. It's a positive imaginary number. Square root of negative 1 is a positive I. There you go.